Hello and welcome. In this video, we're going to take another look at our fundamentals demo, and specifically, we're going to focus on the ability to use the Java framework to write the contents of an object to a file in our file system. Now, this video assumes a couple of things. Number one, that you've already been working with the fundamentals demo and that you've been able to write the get info with object function that allows for you to collect the information from the console or from the command line and ultimately store it in an object of type collected info. If you've not yet got that one working, you will need to go back and watch that video. Additionally, I've already shown you how to leverage batch files to automate some of your input and output, and would highly encourage you to do that as well. So to begin with, what we want to do is sort of understand or appreciate the problem that we have. The idea here is that we have our display info function that would simply write the contents of the object to the console. And essentially, at some point after your application is done running, that information just disappears. Of course, it's still perhaps on the console, but you don't have any persistent data storage. What we'd like to do is, instead of, or in addition to presenting it on the console, we also want to be able to store it in an output file. And we want to have a little more control over it than what we would by simply using a batch file with piping from input files and piping to output files. So to begin with, what we want to do is we want to think in terms of being able to export the information out of the object in some sort of custom format. And to be able to do that, what we want to do is we want to write a function then similar to our display info function that instead writes the contents of the object to a file. So what we're going to do is we're going to keep roughly the same approach. We're going to start off with a public static void. In other words, this is going to be a little more of a procedural approach as opposed to a true object-oriented approach. And we will simply call this function ExportInfoToCustom. We'll talk a little bit about what the custom means in just a second and why we're going to differentiate that. But we want to accept then a argument of type EE333.CollectedInfo. And we're just going to go ahead and keep that same name for right now, that sample collected info. That's perfectly fine, although you could argue it's probably not the best variable name. I'm going to go ahead and start off our comment block with the same reminder that I always mention is that you want to go ahead and complete the parameters, the explanation of each one of the input arguments. And we can also discuss a little bit about the return arguments from this function. For right now, we're going to leave it as a void, but we could consider alternative return arguments. And some would be Boolean, which would just be success or failure. An integer, which would then indicate the number of characters written. And if you wanted to get really fancy, then you could create some sort of custom enum that could give a little more information back to the calling function. But the purpose of this video is to focus on how to actually do the writing of the file using the Java framework. And so to begin with, what we want to do is we want to declare a couple of variables that are of a new class or a new type that we have yet seen. And so the first one is going to be of type java.io.file, and we are simply going to call it output file. Now notice here that we're going to declare these, but we're not going to initialize them. In other words, we're not going to yet use our constructor. You're going to see we're going to have to throw a little bit of logic in here. And we're also going to see a new structure that we have not yet seen called a try-catch in just a second. And then the second object that we're going to need is going to be of type FileWriter. And we are once again going to probably use a variable name that's a little too long. We're going to call this one output FileWriter. Later on, we might improve on some of these file names. Now, you can do this a number of different ways in Java, but this particular way allows for us a little bit of flexibility and gets us a little bit of additional understanding on the differences between a file and a file writer. You can also use additional classes that will allow for us to write to a file multiple times, which we'll cover then in a later video. For right now, we're going to keep this as simple as possible. The output file is supposed to be the file system object. In other words, you can create a file, but then not put any contents in it. The output file writer is what allows for us to actually put contents in our output file. And so it's a little bit different than C, but we're still going to have to do some of the basic error checking that we saw in our C programming language. And so to begin with, what we want to do is ask ourselves a very simple question. What is the name of the file that we wish to write? Well, of course, there will always be the option for hard coding. And if you've watched any of my earlier videos, you know that I'm not a big fan of that, except when it's necessary or if there's purpose behind it. But as an alternative, then what we would like to do is to use the Blazor ID. And the idea is that the Blazor ID is supposed to be unique. Therefore, the file name will be unique. Now, at this point, then, we're going to come up with another question, is that what happens when the Blazor ID has already been used? So, in other words, if the Blazor ID has already been used, the file name has already been used, what do we do? Well, we're just going to go ahead and overwrite it for now. You will see in just a second how we can actually write some logic that would allow for us then to control the behavior based on whether or not the file already exists. And that's, again, part of the reason for using this output file and output file writer approach. So the first thing we want to do is check to see whether or not the Blazor ID has a valid value in it. We're not going to assume anything. So the first thing that we're going to check is to whether or not our sample CollectedInfo.Blazor ID is not equal to null. Now, again, this should have been handled likely in the constructor or elsewhere in the code, but we're not going to make any assumptions because then that would be catastrophic for this particular function. And then the second thing that we want to do is we want to check to see that our sample CollectedInfo.Blazor ID.length is in fact greater than 0. In other words, it could actually be an empty string in addition to being null. Now, if it was an empty string, it would just simply mean that you would get a file name that only has an extension and not a file name associated with it. Not the end of the world, but once again, it's something easy for us to check. And then under the else branch, then what we want to do is simply print out a message to the user that says, error, no valid Blazor ID was provided. Now, do you have to include the single quotes around the name Blazor ID? No, not necessarily. Again, it's just meant to communicate a clear message back to the user as to what went wrong. You can also see where now would be an opportunity for us to use a Boolean return value instead of void, because then what you could do is simply set then the return to false. Again, we're not going to worry too much about that in this particular video, as the focus is mainly on how to write the contents of the file. Now, at this point, we're going to assume that we have useful field value in the Blazor ID. And at this point, we're going to go ahead and say our output file is going to be equal to new java.io.file. And we're going to specify then the sample CollectedInfo.Blazor ID as the name of the file, and we are going to append to it .txt. Much like what we did with our sample for our get info, we're just going to simply store whatever the values are in the collected info in individual text files. Now, at this point, this does not create the file. all this does is this creates an object that represents a file on the file system. Now, what does that get us? Well, it gets us the ability to do things like this, to check to see whether or not the file already exists. And so what we'll do is check to see if output.file exists equal to true. For right now, I'm going to go ahead and purposefully indicate the Boolean value here. You can write the logic without the double equals equal to true. However, I believe that this is clear, especially when you are first learning how to work with Java. And what we're going to do, since we said that we were simply going to overwrite an existing file, we are going to provide a warning to the user, not an error, rather, a warning. Duplicate file contents will be overwritten. And again, you can see how you could combine this perhaps with a scanner to be able to collect a yes or no prompt from the user. But again, we're going to focus simply on writing the file. And then under the else branch is where you would then only write the contents of new users / files. Again, this just gives us a little bit more control over our application's behavior. And at this point, then we know whether or not the file already exists. And so essentially we know whether or not the user already exists. At this point, though, what we're going to do is just blindly overwrite the information if it already exists. And to do that, we will now need to create a new instance of our object file writer. And so we'll start off, say object or output file writer is going to be equal to new java.io.filewriter. And you'll see that we've got a number of overloads here. In other words, there's several function signatures we could use. We could technically have used the third one that would allow for us to simply put in the file name itself, perhaps without even checking to see if it existed. But we are going to use the first overload that accepts an input argument of type file. In other words, our output file that we have already created as a variable. And then what we want to do is we can go ahead and pull up the source in Java to look at the alternate function signatures. And you'll see here that there is our file writer that accepts a single argument of file. You can also look at some of the others. And what we're interested in is this overload that accepts a second argument in addition to the file, accepts a Boolean value of whether or not to append. And so right now we're not too worried about appending. We're simply going to write the contents of the file, or rather the contents of an object, into a new file. And so this is going to open it for writing. Later on, we'll see how to open it for appending. Now, you should get an error, or rather a warning associated with an error. This is unreported exception must be caught or declared to be thrown. Now, if you go back to your C++, you'll know that when we opened a file, we would always have to check to make sure that the file pointer existed before we attempted to write the contents to a file. Fundamentally, this is the same thing that's going on, except for Java requires us to use a new structure called a try-catch. In other words, we're going to try to open the file, and if for some reason it fails, then we want to catch the exception or the error associated with it. And to do that, we simply set up a new structure called a try-catch, and we're going to catch something of type exception. We'll take a look at those later on. And then inside the try-catch block, we will simply move our constructor for our output file writer. So at this point, if you've survived the attempt or the try, then you can be assured that you have an open file, and then you can begin writing to it. If, however, though some exception is thrown, so error or exception was thrown, for right now, what we're going to do is we're simply going to leverage our system.out.println, and we're going to provide a warning to the user or an error to the user that says failed to open file. But we can do something even better. We can go ahead and use the toString method of our exception to tell the user exactly what went wrong. So in other words, you can have not only your own custom message to the user, but you can also use the framework's message to the user by simply calling the toString method. And if you explore a little bit deeper with the exception, you'll see there are other things that you can provide more specific details. But let's focus on how do we actually write the contents to the file. Well, once you have successfully opened the file, we can then use our output file writer, and you can simply then use the append function, which would allow for us then to append some sort of character sequence or a single character, or in this case, what we can do is we can simply use our sample collected info dot, and then of course we could use any of the individual fields and do it one line at a time, or we can call our toString method. And so once again, let's take a look at that. We're going to put a few comments here. We're going to say output file writer dot append. And then what we could do is we could leverage our sample collected info. We could, for instance, simply write only the Blazor ID if we wanted to. We can also put hard-coded values in there if we wanted to. Let's try this again. There's my, not really sure what my autocomplete is doing for me here. It's having a little bit of fun with me here. But you can also put custom text in there if you wanted to. Now, we're not really interested in either of these, but you see then how you feel about doing it. As a matter of fact, we're not even particularly interested in leveraging our toString function, because the idea is that we wanted to make some minor changes to our structure in our file. And again, this is going to seem a little bit arbitrary, but what we'd like to do is we'd like to push the order or change the order of our fields for the purposes of this file. And specifically what I'd like to do is I'd like to push the Blazor ID up to the top. So we see that as our very first contents of our file. Now, you could argue we also see it as the file name. It's perfectly okay, but that way we have the information in two different places. And so what I'm going to do now is I'm going to come over here. I'm going to make a copy of our toString. And I'm going to change it now from toString to toCustom. And again, I'm just going to make a very, very slight change. I'm going to remove the Blazor ID from the third line, and I'm going to put it on the first line. And there's some reasons behind me wanting to do this, and we'll see that in later videos. Fundamentally, the idea is the Blazor ID is supposed to be unique, and it's going to be our unique ID, and that it's just sort of good practice to put the unique ID as the first field. Aside from that, it's just a detail to emphasize that we have now a different function called toCustom. And to prove that we should be able to call it, we can go back now to our ExportInfoToCustom, make a copy of this, and then change our function that we're calling to toCustom. At that point, the only thing that we need to do is gracefully shut the file. So we're going to say output file writer and close. And at this point, then you have successfully closed the file after writing it. You aren't relying on the framework or your operating system to close the file for you. And at this point, we should be able to check to see if we have working Java code, so it builds correctly. And the only thing we have left to do now is to set up our command line arguments. So that means we're going to go back now to our main. If anything, what we can do is we can borrow one of our earlier switch combinations. As a matter of fact, I'm going to borrow our get info with object because it's going to be relatively similar in its behavior and count. We're simply going to change the get info with object now to export info to custom. The steps that we're going to want to do is to capture the information from the user. There's a couple of different ways that we can go about doing that. However, though, we need somewhere to store it. We're going to store it in a variable of type EE333 CollectedInfo. We are simply going to call this our results variable. And remember that this is declared but not initialized, so we need to make sure and get that information from the function, our EE333 fundamentals demo. So in this case, what we're going to do is say results are equal to EE333 fundamentals demo dot get info with object. At this point now, it is initialized, or it's assumed to be initialized inside of the function, and then the return value from the function is assigned to our results variable. Again, you'd want to check this, and this is one of the reasons why we have to check to make sure that the individual fields are null. Right now, are not null, rather. Right now, we're trusting that all of this is working correctly. And then instead of displaying the info to the console, what we want to do is we want to turn around now and we say EE333 dot fundamentals demo dot, and we're going to export info to custom, and we're going to pass to it our results variable. Hopefully that made sense. If you need to go back and review the second part of your get info with object function and the explanation of how we handle that return value, or rather why we changed it from a void to a return value of type collected info. And at this point, we should be able to build it. And you can get some guidance for how to run this from your batch file. What we're going to do is we're going to leverage our input and output by simply changing our switch. And so we'll start off by running Java and then EE333 fundamentals demo. And the switch we're going to pass to it is going to be our export info to custom. And for the input, we're going to leave the output alone. But for right now, the input is going to be our input.txt. And hopefully we don't have any problems, but you'll see here that we have all of our prompts, all of the information for our prompts are coming from our input file, which resides here. And we are still making a call to the display info because we chose in an earlier video not to change that, so you at least see the output on your screen. But if I type in dir, you'll notice that I also have gmyers.txt. And you'll notice that it also popped up in my folder. And if you drag and drop this into NetBeans or open it in Notepad, you will see that I have something that looks very similar to the sample output file, with the distinct difference being that the third row in the sample file is now the first row in my gmyers.txt. And just to see how the behavior would work, if we decided to run this a second time, you'll see that I should get then a warning: duplicate contents will be overwritten. Why did that happen? Well, because we were attempting again to update or create a user with the same Blazor ID. So play around with this a little bit, use some different names. Matter of fact, just quickly for this video, I'm going to just change this to gmyers2 just so you could see the behavior. I'm going to rerun this one more time. And if I type in dir, you'll see there's a gmyers and then a gmyers2. So as always, hopefully you found this video useful. This is going to be part of a continuing series focusing on file input and output. This one particularly focuses on how to write a single file. In later videos, we're going to show how to append, also read. Hopefully you found this video useful. As always, if you have any questions, comments, or concerns, don't hesitate to reach out to me. And thank you for watching.